we will be looking at a very famous qualitative risk analysis approach in this video, and that is the analytic hierarchy process, AHP. Now remember, this is a qualitative risk analysis method. A lot of people tend to confuse it for a quantitative approach, but it's qualitative because you start off with data that's non-numeric and it gets converted to numerical data. So because the data starts off as non-numeric rather than numeric, then you classify it as qualitative. Now, AHP, it's a process that you use to calibrate preferences. So if you've got preferences for achieving different objectives in a project, and you're not sure whether you prefer a certain criteria, let's say, over another, then AHP is a very suitable method to allow you to associate relative weights with each objective or criteria. And an example is given over here for you guys. So let's say I'm an organization that's looking at adopting several technologies. So I've got a couple of alternatives, and just say that I need to compare between these alternatives. To compare between these alternatives, I've identified a number of objectives or criteria. So four of them: cost, efficiency, running cost, and durability of product. Now, each technology is associated with a cost, a certain efficiency level, a running cost, and a level of durability. So 5 for durability being the highest, 1 being the lowest. What we notice is that there's always a trade-off. So if we look at technology C, the cost of that is $4,000. The durability of that is 4 out of 5. Compare that with technology D. It costs less. It has a higher durability. However, in terms of efficiency, technology D is lower than technology C. So a lot of times we're not really sure whether we prefer cost over efficiency, or do we prefer efficiency over durability, or do we prefer running cost over efficiency, etc. And that's the purposes of AHP. It would allow us to determine which objectives we desire the most to achieve, and as a result we can prioritize these objectives, and it would also enable us to create an overall project risk priority list from the risks that have been assessed on their implications for individual objectives. So if there are objectives or criteria that are identified as very desirable, then any risk that impacts that objective would of course be given a really high priority in our risk priority list. But how do we achieve that comparison? Well, that's what AHP helps us to do. So that criteria, the comparison between the criteria would be achieved through AHP. Now remember, when I go through the steps, there's about 5 steps that I'll be going through in the example that I'll demonstrate. These numbers that you see in this table wouldn't really matter much. These numbers are just an example, an input that you would be expected to deal with when you've got several alternatives that you have to make a choice out of. But the important thing is that we need to follow a systematic procedure. So let's start off with step 1 in the process. So step 1 involves building this hierarchy. So this is level 1, this is level 2, and this is level 3. So level 1 is usually the goal that you are trying to achieve. Level 2 is your criteria or your objectives. And level 3, that's the alternatives. So any situation that you face where you've got, a goal that you desire to achieve, and to help you achieve that goal, you've got a set of criteria that you need to analyze. And for each criteria, there's a number of alternatives. You'd know that AHP would be a very appropriate method to use. So that's step one. So establishing the hierarchy, understanding what your goal is, understanding what the criteria is, and understanding what the alternatives are. The second step, and this is the most important thing, is generating the pairwise comparison matrix. That's the input that's most important. So not the numbers over here that you've seen. So not these cost, efficiency, running cost. These are just, they report on the criteria, but we need to establish the comparison between the criteria. And to do that, we need to use what we refer to as the scale of relative importance. And a scale of relative importance is given, an example of that is given over here. Now, you will see different scales of relative importance utilized. This is the one that I prefer. So scale starts with 1, and number 1 means that you equally prefer the criteria. So if I've got criteria 1, let's say this is criteria 1 and criteria 2, and I'm comparing between both of them, right? So if I put a 1 in my matrix, the value of 1, it means that both of them are preferred equally. What if I had, let's say, a number 3? A number 3, from the scale you can see moderately preferred. That means that in terms of criteria 1, I moderately prefer criteria 1 to criteria 2. If it was a number 5, then it means that I always prefer criteria 1 over criteria 2. So in the matrix, and you'll see that in the third step, we always sort of, when the comparison, we do it based on the row. So we look at the criteria that's on the row, and the row over here is criteria 1, the column is criteria 2. So criteria 1 with respect to criteria 2. If I've got number 5, criteria 1 is always preferred to criteria 2. If I've got number 2, criteria 1 is mildly preferred to criteria 2, etc. Okay, so now that we've understood the way in which we read the matrix and the numbers that are used, just before we move to step 3, there's this important thing, and that's the inverse. So we have these numbers that we associate when we're comparing criteria, and then we adopt the inverse. And the inverse is important when we are going the other way around. So let's say, for example, criteria 1 in this case relative to criteria 2. So I mildly prefer criteria 1 because I have number 2 relative to criteria 2. If on the same matrix I had, when it gets to criteria 2 with respect to criteria 1, because I've already established that criteria 1 respect to criteria 2, I mildly prefer criteria 1 with respect to criteria 2, give it a number of 2. For the inverse, the other way around, it's 1 over the number, so 1 over 2. Okay, so that's the number over here. And this will become clearer when we have a look at the input matrix. So the step 3 is the input matrix. And the input matrix is what you see over here in front of you. Now this is input, so this is up to the decision maker. This is not, numbers that you can generate yourself. This is where you have to interview the decision maker and see how they view each criteria with respect to the other. So let's look at purchase cost. Purchase cost relative to efficiency. So purchase cost in this case, number 3, and number 3 from here, it's moderately preferred. So purchase cost is moderately preferred to efficiency. When it comes to running cost, purchase cost is always preferred so purchase cost is always preferred to running cost. And for durability, purchase cost is mildly preferred to durability of product. Okay, so these are the number. So the first step in filling out this matrix is you have to fill the diagonal, and the diagonal is always going to be 1. So when you're looking at purchase cost, right? So that's the diagonal. You have a number 1. Again, efficiency versus efficiency, number 1. Running cost versus running cost, always 1. Durability, always 1. So start off by filling the diagonal first, and it's always a number 1 that will be associated. Next step is to fill out the numbers for the criteria where you prefer. So starting off from the row, if you prefer purchase cost over efficiency, then you give it a number, a whole number, right? Instead of a fraction. The fractions, leave them till the end. So let me delete the fractions over here and let me show you how you would do them. Because there's a very simple way of doing it. Okay. So let's say, we've went through the first row, so purchase cost. We've done that example. Let's move on to efficiency. Efficiency relative to purchase cost. So you don't prefer efficiency over purchase cost on that scale from 1 to 5. So what you do is you need to, so if that's not the case for purchase cost, you just move on. When it comes to running costs, you do have that preference of efficiency over running costs. So you associate it with a number 3. That's moderately prefer. So you moderately prefer efficiency relative to running costs. That's why I have a number 3. And then I put a number 4 over here for durability of product. Okay, so notice that I left this out. Again, for running cost, I left this out. And durability, I only have it for running cost. So I prefer durability over running cost, and the preference is greatly prefer, and you can see that from the scale above. Okay, how do we fill out the rest of these values? The rest of these values, you just use the inverse. So this is a matrix, triangular matrix, so you have a diagonal and it's symmetric. So purchase cost relative to efficiency, you gave it a number 3. So purchase for efficiency relative to purchase cost, which is the inverse, it's just going to be 1 over 3, right? So that's this value, but the inverse of that, so 1 over 3. And likewise for running costs. So you can see it's like the transpose of that. So this is the row that I'm looking at, and this is the column that I'll be filling. So that will be 1 over 5 because I've got a 5 over here. And because I have a 2 over here, that's going to be 1 over 2. So the inverse. Likewise, in this case, I'm looking at running cost efficiency. So efficiency running cost, I gave it as a value 3. The inverse of that would be 1 over 3. And let me just, okay, so 1 over 3. And then for durability of product and efficiency, I'd use the inverse, so efficiency durability, I gave it a 4. The inverse of that would be 1 over 4. So notice that this is exactly the transpose over here. So this row is transposed, but it's given the inverse in that column. Okay, likewise for the row above. So we take the inverse, and we generate these numbers. So finally, over here I gave for durability with respect to running cost. Okay, so looking at durability and running cost, I gave it a 4, so I prefer durability over running cost. When it comes to running cost, the inverse running cost and durability, which is that figure over here, it's going to be the inverse 1 over 4. Okay, so that's how you complete your input matrix. Remember, start off with the numbers on the diagonal, then the whole numbers, and then fill out the rest of the boxes by taking the inverse. Okay. All right. So step 4. Step 4 is where it's exactly, these are the same values that we had above, but we need to add the columns. So each column has to be added. So you can put on a total over here. So you just add an extra row, and that's where I will have the sum of each column. So the sum of the first column, so if you add this plus this plus this plus this, you should get 2.03. If you add this plus this plus this plus this, you'll get 4.58, etc. So continuing on, 13 and 7.25. This is very important because we'll be utilizing these total values to normalize the numbers that we have in the matrix. That's step 4. Step 5, this is where the normalization process takes place. So we've already calculated the total for each column, I'm going to use in step 5, I'm going to use that total to normalize each of these values in my column. So to normalize the first one, it's going to be 1 divided by the total. To normalize the second value, it's going to be 1/3 divided by 2.03, and so on. And that's what I'm doing over here. So you notice that this is the total value, 2.03 for the column. That's the total value. And I'm dividing each number that I had in the matrix by that total value from the column. So it's for that column, it's always 2.03 that I divide over with. So 2.03, 1 divided by 2.03, that will give me 0.49. And I do that for the remainder of the values in the column. And you should be getting these values 0.16, 0.1, and 0.25. Okay, likewise, we do the same for efficiency. So efficiency, it's 4.58, the total for the column. To normalize that column, so it's the input that was there, so 3 divided by the total, and you should be getting 0.65. 1 divided by 4.58, you should be getting 0.22, and you keep on, filling the value 0.07, and then finally it's 0.05. Okay, so you don't worry about this final column. That's just the total. Okay, let's move on to the third column, the running cost, 5 divided by 13, which is the total. For that, you should be getting 0.38. 3 divided by 13, that's 0.23. That's 0.08 and 0.31. Okay. And finally, the final column, 0.28, 0.55, 0.03, and 0.14. What do we do after that? So we've normalized each value. The next step would be to add each row. So the way to do that is for purchase cost, add the values that we have. So I've got a 0.49 over here. I've got a 0.65, I've got a 0.38, and I've got a 0.28. So I need to add these up, and that will be my criteria weight. So I have to have a new column, and I label that as criteria weight. So in that column, it's 0.49 plus 0.65 plus, probably need to shift a bit, 0.38 plus 0.28, and we divide that by 4. So we're taking the average of all these numbers as an answer. You should get 0.45. Okay, likewise, you have to do the same for each of these rows. So for this row, for efficiency, you should be getting 0.29, 0.07, and 0.19. So remember, for this step, we're doing the addition across the row, and then you divide by the total number, which is 4. All right. What you would notice is that if we add up each of these individual weights, we should be getting 1, and that's how you know that you've done the calculation correctly. So that should add up to 1. Basically, what we're saying over here is that we've got several criteria that we're looking at. So criteria number 1 is the purchase cost, criteria 2, efficiency, running cost, and then criteria 4 is the durability of the product. Now, each criteria, we need to associate a certain weighting. How important is it to the decision maker? After we've done the calculation, we figure out that the most important weighting that's given is for purchase cost, and that's given a weighting of 0.45, so 45% preference over the other criteria. When it comes to efficiency, there's a 29% preference. When it comes to running cost, 7% preference, And when it comes to durability, there's a 19% preference. So the highest preference is given to purchase cost, second preference is given to efficiency, third preference is given to durability, and final preference for the particular decision maker that we analyzed in this case is given to running cost. And as I said, these these numbers all have to add up to 1. So I would know after conducting this analysis, I'd know that anything that impacts my purchase cost, because it's given the highest relative weight, any risk that impacts this cost would always have the highest priority in my priority risk list. Anything that impacts the running cost, any risk that impacts the running cost would be given the lowest priority on the priority risk list. Some final points before we end the video. The diagonals, it's always a 1, remember that. Preference factors are input per row, so you look at it per row, and just like what we did up there, so per row, purchase cost, and then see if you prefer it over the criteria that I given. If you do have a preference, then label it. Is it a mild preference? Is it a moderate preference? Give it a particular scale. And then for the remaining values, just use the 1 over the preference factor. So you just use the inverse, because remember, this is a symmetrical matrix. So use the diagonals, the 1, and then adopt the inverse values.